At first it looked like a curiosity, a single unusual data point. Then it kept happening. In 2020, timekeepers recorded 28 of the shortest days ever measured since atomic clocks began keeping watch. In June of 2022, Earth broke its own speed record again, completing a full rotation 1.59 milliseconds faster than the standard 24 hours. Then, on July 5th, 2024, our planet set the record that still stands today as the single fastest rotation of the entire atomic clock era, 1.66 milliseconds shorter than a normal day. Across the summer of 2025, the pattern intensified further, a string of unusually fast days rolling through July and August, each one a fresh entry in a growing catalog of anomalies nobody had fully predicted. Studies suggest that factors like melting glacial ice, rising seas, and depleted groundwater have been changing the distribution of Earth's mass in ways that would normally be expected to slow the planet's rotation, the same way as spinning ice, skater slows down by extending her arms outward. And yet, despite all of that, Earth kept spinning faster. Leonid Zotov, one of the world's leading authorities on Earth's rotation, working out of Moscow State University, put it about as bluntly as a scientist ever does. Nobody expected this. The cause of this acceleration is not explained. Ocean models cannot account for it. Atmospheric models cannot account for it. Most researchers now suspect the true answer is hiding somewhere we cannot directly see, deep inside the planet itself, in the slow, churning motion of Earth's molten core. A place where matter under crushing pressure and searing heat shifts in ways that can subtly alter the mass distribution, and therefore the spin of the entire world above it. It is one of the strangest sensations in modern science, watching a measurable, undeniable effect ripple across an entire planet while the cause remains locked away. In a region of the Earth no human instrument has ever directly touched. And here is where the story becomes genuinely unsettling, because Earth's spin is not the only thing changing. So is our understanding of who exactly is responsible. For years, researchers assumed humanity's environmental footprint on this planet was too small to meaningfully alter something as massive as Earth's rotation. Then, a landmark study led by geophysicist Duncan Agnew and published in the journal Nature revealed something almost paradoxical. Climate change itself has been quietly interfering with the planet's spin, and in the opposite direction most people would expect. As glaciers in Greenland and Antarctica melt, that meltwater does not simply vanish. It spreads out across the world's oceans, redistributing an enormous quantity of mass away from the poles and toward the equator. And just like that ice skater extending her arms outward to slow her spin, that redistribution of mass has been acting as a very real, very measurable brake on Earth's rotation. And one of the great ironies buried inside this story, the same climate crisis reshaping coastlines and ecosystems around the world, has, in effect, been the thing holding our accelerating planet back from spinning even faster. Agnew himself put it in stark terms. Had that ice not melted, had the planet not warmed the way it has, we would likely already be facing the need for history's first negative leap second, or would be right on the very edge of it, which raises the strangest, most consequential question in this entire story. What happens when the planets spin and our clocks stop agreeing with each other? Since 1972, the world has relied on a system called Coordinated Universal Time, an atomic timekeeping standard so exact it never wavers, stitched carefully to the far messier, ever-fluctuating reality of Earth's actual rotation through an occasional adjustment called a leap second. 27 of these leap seconds have been added to global clocks since 1972, each one a tiny correction inserted to keep atomic time in step with the slow, historically predictable drift of a decelerating planet. But a system built entirely around the assumption that Earth would keep slowing down has now run headlong into a planet that, for reasons still not fully understood, has started speeding up instead. No leap second has been added since 2016, and for the first time since the entire system was invented, scientists are now seriously discussing the unthinkable. A negative leap second, an instant where, for the only time in the history of modern timekeeping, civilization's clocks would have to skip forward, deleting a single second from existence to keep pace with a planet spinning just a little too quickly. It has never happened before, not once, in the more than 50 years since atomic timekeeping began. And unlike the ordinary leap second, which computer engineers have spent decades learning to handle, a negative leap second is something almost no software system on Earth has ever been built or tested to survive. Engineers at Meta, one of the companies that has studied this scenario most closely, have warned in blunt terms that it could have a devastating effect on any software relying on timers or schedulers systems quietly running in the background of banking networks, telecommunications, infrastructure, satellite navigation, and the invisible machinery that keeps modern civilization synchronized. One Agnew himself estimates the odds of it actually happening somewhere between now and 2035 at around 40%, a coin flip hanging over the architecture of global timekeeping. In 2022, the international body responsible for the world's time standards voted to phase the leap second out entirely by 2035, a decision made, in part, specifically to somewhere in a windowless laboratory, a network of atomic clocks, machines so precise they would not lose a single second over the next 100 million years, has just detected something that should not be possible. Earth, the planet beneath your feet, the one thing in your entire life you have always assumed moves with perfect, unshakable consistency, is not spinning the way it is supposed to. Some days it finishes its rotation early, milliseconds early. And nobody, not the world's top geophysicists, not the scientists who have spent their careers timing our planet down to the trillionth of a second, can fully explain why. This is not a doomsday story. Earth is not spinning out of control, and it is not about to fly apart. But something genuinely strange has been happening to the length of our days, something so subtle that no human being has ever felt it, and yet so significant that it is now forcing timekeepers, satellite engineers, and scientists at NASA to rewrite the rules of how we measure time itself. And the closer they look, the stranger the story gets. To understand why a handful of milliseconds could matter to anyone, you first have to understand what a day actually is. We treat 24 hours as a fixed, sacred unit, the heartbeat against which every human life is measured. But a day is not a law of physics. It is simply the time it takes our planet to complete one full spin on its axis. And that spin, it turns out, has never once been perfectly steady. Earth is not a smooth, rigid ball rotating in a vacuum with nothing to disturb it. It is a churning, shifting living system, oceans sloshing across its surface, an atmosphere in constant turbulent motion, a molten iron core swirling thousands of kilometers below our feet, ice sheets growing and melting at the poles, and a moon tugging at all of it from 250,000 miles away. Every one of those forces reaches into the rotation of our planet and nudges it, ever so slightly, faster or slower. Earth's spin is not a fixed rhythm. It is a negotiation between a dozen unseen forces, playing out in real time every single day. For most of human history, we had no way of detecting any of this. A day was a day. The sun rose, the sun set, and no clock on Earth was accurate enough to notice the difference of 1,000th of a second. That changed in the 1950s and 60s when scientists built the first atomic clocks, devices that measure time not by the swing of a pendulum or the tick of a gear, but by the impossibly precise, unchanging vibration of atoms themselves. For the first time in history, humanity possessed a stopwatch accurate enough to catch our own planet in the act of cheating the clock. And almost immediately, the atomic clocks revealed something scientists had long suspected but never proven. Earth's rotation was slowing down. Over the vast span of geological time, the story is dramatic. Roughly 2.5 billion years ago, a full day on this planet lasted only about 17 hours. A study published in 2023 found that between 1 and 2 billion years ago, a single Earth day may have stretched to only around 19 hours, a planet spinning so much faster than it does today that had human beings existed then, an entire lifetime would have contained millions more sunrises than a lifetime does now. The reason for that ancient deceleration has a name, and it is hanging in the night sky above you right now, the moon. Every single day, the moon's gravity reaches across the emptiness of space and gently drags at Earth's oceans, at the rock beneath them, at the planet's own rotation, acting like an enormous invisible brake. That braking effect gradually transfers our planet's rotational energy outward, and it has to go somewhere. It goes into the moon itself, which spirals slowly, patiently away from us, gaining just a little more orbital energy with every single Earth rotation. Right now, at this very moment, the moon is drifting away from Earth at a rate of roughly 3.8 centimeters a year, about the thickness of a human fingernail. It sounds insignificant. Multiply it across the deep abyss of geological time, and it becomes the very engine that has been stretching Earth's days longer and longer for billions of years. For decades, that long, slow deceleration was the entire story. Scientists could track it, model it, and comfortably predict it. Then, starting around 2020, the atomic clocks began recording something that broke the pattern entirely. Earth stopped slowing down, it started speeding up. Avoid ever having to trigger this untested, potentially destabilizing correction. Whether Earth's rotation will cooperate with that timeline is, quite literally, completely out of our hands. But there's a second, quieter danger buried inside all of this, one that has nothing to do with software calendars and everything to do with where you are standing on the planet right this second. A single millisecond of unexpected variation in Earth's rotational speed can translate into an error of roughly 1.5 feet in the location calculated by GPS satellites orbiting far overhead. That sounds trivial until you remember exactly how much of modern civilization now depends on GPS being correct down to the meter, commercial aviation navigating through crowded skies, precision agriculture guiding autonomous and tractors across enormous fields, emergency responders locating exact addresses in disaster zones, financial markets that stamp every single transaction with a synchronized timestamp accurate to fractions of a second. Earth's rotation is not simply an abstract curiosity for astronomers anymore. It has become a hidden variable embedded directly into the infrastructure of daily human life. And every unexpected wobble sends a small, cascading correction rippling through systems most of us never think about at all. So scientists watch. Every single year now, timekeeping agencies around the world, chief among them the International Earth Rotation and Reference System Service, track the length of each day with an almost obsessive vigilance, publishing predictions for which dates are expected to be the shortest of the year, and then checking, with atomic precision, whether the planet actually behaved the way the models expected. In the summer of 2025, 3 dates stood out as candidates for the shortest day ever recorded: July 9th, July 22nd, and August 5th. Each one arrived close to a full 1.5 milliseconds shorter than a standard 24-hour day. None of them broke the all-time record set back in July of 2024. But together, they added yet another entry to an already remarkable, still unexplained pattern. A planet that, for reasons buried somewhere between its molten core and its shrinking polar ice, keeps quietly breaking its own speed limit. And then, just as suddenly as it began, the story took another turn. By mid-2026, the same scientists who had spent years chasing record after record of Earth's fastest days started noticing something new. The trend appeared at last to be reversing. According to mid-2026 projections from the International Earth Rotation and Reference System Service, this year's shortest day is expected to fall around negative 0.65 milliseconds, more than half a millisecond longer than the record, setting shortest day of the previous year. Zotov himself, the same scientist who had spent years insisting the acceleration remained a genuine mystery, began to shift his language. It seems, he noted, that Earth has started to decelerate, and the most extreme lengths of day may have already been left behind in 2024. If that assessment holds, it would mean our planet just lived through a strange, unpredicted multi-year sprint, one that appeared without clear warning, defied the models built to explain it, and now, just as mysteriously, appears to be easing. But scientists have been fooled by this planet before. Zotov himself once predicted an earlier slowdown, only to watch Earth accelerate again the following year, breaking new speed records nobody expected. That is the deeper, more unsettling truth sitting at the heart of this entire story. We built machines accurate enough to detect the heartbeat of an entire world, and what we discovered is that the heartbeat is not steady. It never really was. We simply never had the tools to notice before. There is a strange kind of humility in that realization. We tend to think of Earth as a fixed backdrop against which human history unfolds, solid ground beneath fleeting lives, a stage that never itself moves. But the truth revealed by decades of atomic clock precision is something closer to the opposite. Earth is alive with motion at every scale, from the vast, ponderous drift of a moon slowly abandoning us across billions of years, down to the sudden, unexplained acceleration of a single afternoon in July. Wind patterns thousands of kilometers wide, ocean currents circulating unseen beneath the surface, glaciers releasing meltwater into rising seas, and somewhere far below, in a churning ocean of molten iron, nobody has ever seen. With their own eyes, forces are at work that can immeasurably alter the spin of an entire world. And we are only now, for the very first time in the history of our species, precise enough to notice. This is not a story with a tidy ending, because the science itself has not reached one. Researchers do not yet know exactly why Earth accelerated so sharply after 2020. They do not know with certainty whether the recent slowdown will hold, or whether the planet has one more surprise acceleration waiting in the data. What they do know is this: the tools we now have, atomic clocks capable of measuring time down to fractions of a billionth of a second, satellite networks that can pin a location to within centimeters, decades of continuous unbroken observation, have given humanity something no earlier generation ever possessed. The ability to actually watch our planet think, to catch it in the subtle, restless act of shifting its own weight, redistributing its own mass, and quietly, invisibly, rewriting the length of the single unit of time every human being on Earth has always assumed was permanent. Somewhere right now in laboratories scattered across the globe, in Moscow, in Paris, in the quiet control rooms of the U.S. Naval Observatory, scientists are watching. The readouts scroll past, waiting for the next fraction of a millisecond to reveal itself. They are not waiting for a catastrophe. They are waiting for understanding, for the moment when the pattern finally makes sense, when the churning core, the melting ice, the drifting moon, and the restless atmosphere all finally click together into a single coherent explanation for why the ground beneath every human being alive keeps, ever so slightly, refusing to behave. Until that day comes, one truth remains, quiet, strange, and impossible to ignore. The planet you are standing on right now is not the same planet it was yesterday. It is spinning at its own pace, following its own hidden rhythm, and for the first time in human history, we are finally precise enough to hear it.